Hi everyone, my name is Maria Paula Ramos. I'm geoscientist and FastTIME volunteer. Welcome to Geophysics Champions, a space created by this electronic news magazine of near-surface geophysical community. On this occasion, we are joined by Adriana Ocampo. She's planetary geologist, I love planetary science, and NASA's New Frontier-led program executive. Listen what she had to say about the application of near-surface geophysics in past NASA missions. Go ahead. Okay, Adriana, we assume or we suppose that the application of the near-surface geophysics in the past NASA missions have been valuable in the process to understanding the gravitational field, magnetic field, and different structures of the planets such as Jupiter, Mars, and Pluto. What do you think that is the most important contribution of these missions related to geophysics? For example, New Horizon, Mars atmosphere and volatile evolution, or Juno?
Well, all of them are extraordinary feats of human exploration. They have really advanced our knowledge by leaps and bounds. They have rewritten, the science textbooks. If we start with New Horizons, for example, the first time we went to the farthest edge of our solar system to explore the dwarf planet Pluto. It was an extraordinary journey of almost 10 years that it took to arrive to Pluto and the Plutonian system with its Charon, which is the largest moon of Pluto. The New Horizons team actually discovered several other moons like Nixa, Hydra. So now Pluto really has five moons. And one of the ways that for example, that New Horizons was able to determine the mass of the planet and the radius is that during the flyby on July 15th, or July 14th of 2015, I'm sorry, when the trajectory is determined to such an accuracy that any deviation in that trajectory, it means a change in the gravitational pull of the spacecraft as it flies by the planet or a stellar object. It could be an asteroid or anything. And that was the same technique that New Horizons used to determine the mass of the body. And then by that, they were able to determine the density, and they had, infrared spectrometers and also in the UV, infrared, and visible that were able to take imaging and determine composition. So that gave us an incredible, we expected Pluto to be really a dead planet, in a sense, a dead minor planet, and yet it showed us incredible, a lot more activity in that we found large glaciers with potentially, lakes underneath. So Pluto is really another potential, planet with an ocean or minor planet with an ocean. And so the geophysical techniques gave us the opportunity to inform all this new data that was gathered by the New Horizons mission. And the same way, Juno has a different set of instruments on board. It is more focused on trying to understand, penetrate this the largest gaseous planet in our solar system, and be able to determine, does Jupiter still have a nucleus, a core underneath that thick layers of clouds? And that was one of the key questions that the Juno team wanted to try to understand, because it could have been that maybe when Juno arrived to Jupiter, the core would not have existed. It could have dissipated by the time, but they were able to observe a core in Jupiter. And that's, again, very important in trying to understand the evolution of planetary formation. So all these missions have carried a set of instrumentation that really have provided us key information to understand really the evolution of our solar system, how planets are formed, the difference in their composition. One of the key questions that we want to understand is how the water molecule arrived to Earth, which we know water is key for life as we know it. And through these missions like New Horizons and Juno, and we're able to really be able to then put that puzzle together. We know in the early solar system, Jupiter may have acted as a big, in a sense, like a blender, was bringing all the molecules from the outer edge of the solar system into the inner solar system, into the inner planetary area region, and that may have been the way that the water molecule was eventually also captured by the Earth. Is one of the theories, as well as potentially, having the water molecule being implanted by impacts like comets and asteroids that we know impacted in large quantities during the bombardment period 4.5 billion years ago, the formation of the solar system. So it is a very complex questions that are being addressed, but today, thanks to all these different robotic spacecraft, we are much better informed, and we are understanding better our place in the solar system and the universe.
Okay, Adriana, now that you mention it, my favorite, I think, that is Mars Recognized Orbiter, because we are speaking about different methods to measure gravity and different aspects of the planets. And it's my favorite because have a lot of things, include HiRISE, for example. I had the opportunity to work with HiRISE images, and HiRISE has an excellent spatial resolution. And also, Mars Recognized Orbiter has gravity radio space science field investigation package, where study Doppler shift of the radio communication signal to determine the gravitational field, and I think that is amazing.
Yeah, those are very good points, Maria Paula. Exactly. The Mars Reconnaissance Orbiter is an extraordinary mission. It was such long duration. We were able to get a really big, strong baseline on the evolution of Mars, and with a gravity experiment, the Doppler shift that we're able to determine, and we know today that Mars, is half the size of the Earth. Mars doesn't have the magnetic field that the Earth have. It really has is fossilized magnetic fields. It really, and we're trying to understand what happened to the core, to that the dynamo there that made the magnetic field of Mars go quiescent. And so those are all big questions. And again, in Mars, we don't have the classical plate tectonics like we do on Earth. So it's a very different type of pseudo-tectonism. It builds in layers, like Olympus Mons is an enormous volcano that it has been building through millions of years, So the key question is Mars still active? And, to follow up the great legacy of MRO, that's why the InSight mission was sent to Mars with the specific intention or science objective to really investigate and inform the geophysical aspect. If Mars was still active, then, we should be able to detect Marsquakes. And in fact, the InSight mission was able to detect about at least 174 Mars quakes. So we know that Mars is still basically what it is believed is that it's still like shaking or trembling from the 4.5 from the cooling that is happening since 4.5 billion years ago that the planet formed. So that's one of the theories of what is happening, and that geophysical data through seismic activity we're able to learn more about the thickness of the layers of the planet, the size of the core, and the crust. And we know the Martian crust is at least double that of Earth. It's much thicker. So it's one of the things that we know for mountain building, for tectonic activity, we need to have water also. Water plays a key aspect, oceans. And it seems like, during the time that the Earth was forming and Mars was forming, and either Venus was forming, they all had potential oceans. So what happened to dissipate all the water, and how that has been imprinted now, what we see of the Mars today's Mars, in which tectonism was not able to fully evolve, but it really is more of a pseudo-tectonism in which you find building by layers instead of fractures, and as we see, so it's very interesting. That's why we do a lot on planetary geology, is compare planets to learn more about the Earth.
It's a huge science, and I think that Mars has a lot of surprise for all of us. And now let's talk about Lucy.
Okay.
In a recent NASA interview, you mentioned that Lucy has a silver antenna in front of the spacecraft to perform gravity measurement experiments, and this can be related with density and matter. Can you tell us more about the goal of this experiment? Maybe all of this can be create a gravity map of these asteroids, as was done with asteroid Vesta before. And I think that is amazing. So you can tell us more about this?
Yes, absolutely. One of the key things that we need to differentiate, the Lucy mission will be the first time that we'll go and explore the Trojans. And it's an extraordinary mission because with one spacecraft, we're going to have 8 flybys of 8 different asteroids, including 7 of those being Trojans and 1 in the main belt asteroid. And for example, Vesta, which was explored by Don, it really was an orbiter. In orbit, the Vesta body for a long time, so you were able to build that gravity map. With the Lucy mission, since it's a pioneer first time, it's a reconnaissance mission, we're going to do all flybys. We're not going to be orbiting. So we are going to be collecting really the mass data by using the radio science experiment and determining the mass of the object as it flybys. And again, as I described before, with any trajectory deviation could then determine the density or the mass of the object that we would be flying by. So Lucy is an exploration mission of the Trojans, a region that we never explored before. The Trojans reside just what we call in the Lagrangian point 4, which is in front of the orbit of Jupiter, and Lagrangian point 5, which is in the back of the orbiter of Jupiter. So it's a family of asteroids that we really know very little about. And, we need to learn how they differentiate from the main belt asteroids. We need to learn how they differentiate between, for example, the Kuiper belt, which is way, way at the edge of our solar system. So there are all these objects that are remnants from the period of planetary formation. And we want to go to the Trojans with Lucy to really decipher our origins in our solar system, as Lucy is the namesake of the humanoid fossil that it was discovered in Ethiopia that gave rise to understanding the origins of our species. And Lucy will do the same by understanding the origins of the remnants of leftover of the solar system that are represented by the Trojans asteroids.
Remember, for people who saw us and are interested of planetary science research, planetary geophysics research, geophysics data can be found on Planetary Data System page and also in Planetary Geodynamics data archive too.
And I'd like to invite everybody in the audience to see, to follow the steps of the NASA exploration in the NASA website. We have them in Spanish too, ciencia.nasa.gov, or spacescience.nasa.gov, and you are all welcome. And Lucy will be launching October 16 of 2021, so you are all invited to join us.
Yes.
Most likely will be virtually, but please keep your eyes on the NASA website, lucy.nasa.gov. You'll be seeing the link to join us for the launch. Thank you so much for the opportunity to join you today.